All right, these are notes from chapter 5.2, natural log integrals. So first, recall the derivative rule from first semester where we said that the derivative of natural log of u is simply equal to 1 over u times u prime, or u prime over u. And if we take the inverse process, then it should make sense that the derivative of 1 over u, or some form of integral of 1 over u, will take us back to our original function of natural log of u. Okay, so that leads us to the rule that we have to learn for this section. The integral of 1 over u du is equal to natural log of the absolute value of u plus c. Okay, remember that the angle or the value inside natural log has to be positive, so we ensure that by putting absolute value bars around the function here. Normally, if we see something like 1 over x or 1 over u, we may consider that we may be able to find the integral using power rule. But anything that is in the form of 1 over u to the first power or 1 over x to the first power, power rule is actually going to fail. All right, if we attempted to use power rule, then we will have to try this by rewriting 1 over u as u to the negative 1, right, in order to bring the variable up to the numerator. And if you go through power rule, which says that we add 1 to the current exponent and divide by that new exponent, negative 1 plus 1 will be 0. So then u to the 0 over 0 would be undefined. So power rule fails if we try to apply it for a function that is 1 over u, or 1 over u to the first power. So that's why we have this natural log integral rule to take care of this specific instance. Okay, let's look at example 1. Part of the challenges with these types of problems are just going to be first identifying which u value would make this work. Now, I would like to stress that as you go through and try and find the appropriate integral rules, always see if you can resort or rely on simply using power rule. Okay? But in this case, power rule will not work because we cannot split this into individual terms. So we look at u substitution. Okay? This is not always going to be the case, but a lot of times it is easier to cancel out the remaining x that is sitting up in the numerator than it is to be canceling out something in the denominator. Also, we may have a pretty good guess with the u value being the denominator because we know if we think forward into the problem, we can think about the fact that x squared will turn into x to the first power, right? The derivative of a function that is in the form of x squared, a polynomial, is always going to go down by 1 degree. So if we let the u value be x squared plus 1, we find the derivative with respect to x. So du over dx is simply equal to 2x because x squared turns into 2x. 1 goes to 0. If we cross multiply, solve for dx, we get du over 2x. And our next step is simply trying to plug back into the original function in terms of u and see what cancels out. So x squared plus 1 gets replaced with u. 2x remains for now. Dx gets replaced with du over 2x. The 2x's cancel out. We're left with the integral of 1 over u times du. Now, we do have a specific rule that we just learned. So integral of 1 over u du is simply equal to natural log of the absolute value of u plus c. However, u is just an intermediate variable. We have to present our answer in terms of the original variable, which is x. So u, we know, is equal to x squared plus 1. So we replace u back in terms of x. So we get natural log of absolute value of x squared plus 1 plus c. All right, number 2, the indefinite integral of 1 over x natural log of x dx. We can't rely on power rule, and we don't have any integral rule that involves natural log. So we look to use substitution. A couple of choices here. Maybe the u value is x, maybe the u value is natural log of x, or maybe the u value is the entire denominator, x natural log of x. But if you think ahead, you see that we want the u value so that the derivative will cancel out any remaining x's. So if we let the u value be just x, we know the derivative is not going to allow us to cancel out this natural log of x. If we let the u value be x natural log of x, then our derivative would involve product rule, and we're going to be left with a derivative that will not be able to cancel out because we don't have anything that resembles the result of a product rule from x natural log of x. So let's try u value being just natural log of x. Okay, so our u value is natural log of x. The derivative with respect to x, natural log of x, becomes 1 over x, because the rule for natural log of u is u prime over u. So u prime of x, the derivative of x, is 1 over the original function, so 1 over x. Cross multiply, solve for dx. Dx is simply equal to x times du. We make our substitution. The x initially doesn't go away. We replace natural log with u, and then we replace dx with x times du. Now notice that now the x's cancel out, and we're left with a problem that is in terms of u and du, and we have a specific rule for this situation. So integral of 1 over u is simply natural log of absolute value of u plus c, and our u value in terms of x is natural log of the absolute value of natural log of x plus c. All right, number 3, integral of x squared plus x plus 1 all over x squared plus 1. This is a bit of a difficult problem simply because the u value is not going to be very apparent. If we let the u value be the numerator, we will not be able to cancel out the denominator with this derivative. If we let the u value be x squared plus 1, we will be unable to cancel out the numerator. So we have to look to see how we can rearrange this problem so that we can apply the rules that's available to us. Okay, we can split this up into into separate fractions. Think of the whole denominator as one term, and if we rearrange this as x plus x squared plus 1, we can split this up into this x over x squared plus 1 plus the remaining x squared plus 1 over the denominator x squared plus 1. So we're left with this term. Hey, it's not going to be very intuitive that we take this step, but a lot of this is kind of guess and check to see which combination will allow us to apply the rules that we have. So the convenient thing about the second fraction is that this will just cancel out to be a positive 1. So we can treat these as two separate problems, two separate rules. The integral of x over x squared plus 1, if we let the u value be x squared plus 1, then we can cancel out the x with this derivative. So let u be x squared plus 1. Our derivative with respect to x is 2x. dx is simply equal to du over 2x. Make our substitution, integral of x over u times du over 2x. The x's cancel out. We're left with integral of 1 over u times du over 2. This 2 can be pulled out in front as 1/2. So we're left with 1/2 times the integral of 1 over u times du. 1/2 natural log of absolute value of u, therefore 1/2 of natural log of x squared plus 1. Okay, this is the first portion that comes as a result of the first integral. I'm going to treat this integral of 1 as a separate problem. The integral of 1 is simply going to be just x using power rule. So if we combine this together, we have 1/2 natural log of absolute value of x squared plus 1 plus x plus c.